This is my video on chemical rockets to ion drives, the evolution of space propulsion. This PowerPoint will go over the fascinating evolution of space propulsion, mainly the innovation from the raw power of chemical-based rockets and the new sleek efficiency of ion drives. Why propulsion matters. Propulsion acts as the backbone to space travel. Without it, we cannot launch, maneuver, or explore the vastness of space. It's the method of which we seek to explore the stars. The basics of rocket propulsion. Propulsion works with Newton's third law, which states for every action there is a equal and opposite reaction, which when applied to rockets mean that the rocket expels mass backwards, which pushes the rocket forwards. This is simple in principle, but complex in practice. Historically, chemical rockets are the oldest form of propulsion, but still the most commonly used. They rely on the rapid combustion of fuel and oxidizers to create thrust. Notable rockets include Saturn V, Space Shuttle, and the Falcon 9. Why we use chemical propulsion. Chemical rockets are powerful and produce thrust which is ideal for escaping the Earth's gravity. Chemical rockets do have one key drawback though. They are inefficient for long mission. Fuel runs out fast and a large amount of fuel is needed. Looking at solid versus liquid. Liquid fuel rockets offer higher performance and thrust control, while solid fuel rockets are simpler, more reliable, and more storable. Uh, to my right is a graph of the advantages and disadvantages of different fuel types plus the hybrid. Electric propulsion. Electric propulsion, like ion drives, take a different approach. It incorporates electricity to accelerate ions to incredibly high speeds, which creates thrust over time. Ion drives use an electric field to accelerate ions out of the back of the engine. The thrust is very low but very efficient. This allows spacecraft to embark on longer without fuel. Ion propulsion in practice. NASA Deep Space One and Dawn missions have both used ion propulsion to explore asteroids and other celestial bodies. These missions would not have been possible with only chemical rockets. Ion propulsion versus chemical. Uses and viability. Chemical offer raw power and launch capabilities, but what chemical lacks is in where ion propulsion shines, in deep space efficiency, which makes it ideal for long missions. Combining the best of both worlds. The future may lie in a hybrid system, chemical for launch and electric for cruising. New technologies like nuclear propulsion, Hall thrusters, and electric solar sails are already in development. Key takeaway and looking into the future. Space travel had gone a long way from brute force raw power to more a controlled, efficient electric system. Space propulsion have evolved and is still evolving, bringing us closer to reaching the stars. Key takeaways are chemical rockets offer high thrust but low efficiency. Ion drives offer low thrust but high efficiency. Engineers are to combine both for optimal performance.